Welcome back to Beyond the Blocks. This week we've got a deep dive into server authority, Roblox's answer to cheating, and keeping everyone in sync while allowing smooth prediction on the client. But first, we're your hosts. I'm Adam.
I'm Fedor.
And I'm Anthony.
So Anthony, in case anyone watching or listening doesn't know what server authority is, just give us a quick rundown on what it is, how it works, just give us that background context.
So server authority is a new beta feature that Roblox are working on, and it's one of those really exciting beta features that could possibly have a huge impact on the platform as a whole. So Slim is probably another one alongside of it. And it's this really exciting technology that basically is designed to put an end to cheating, things like speed hacks, shooting through walls, or even in a game where you're driving around and have collisions, making sure those collisions are accurate, and basically stopping people from exploiting and doing dodgy things with their physics. Because right now, on Roblox, the way physics works is each client calculates their own physics, which is great for efficiency because all of the workload is distributed across all of the players. So Roblox's servers can easily handle 50 people driving buses in my game, perhaps. And it doesn't take the extra stress, right? Because each client is doing its own calculations. But that does come at the drawback of you're trusting the client, which is something that security nerds say you should never, ever do. So how does it work? Well, basically, simulations now run both on the server and on the client. Because if we just ran them on the server, then you'd have a massive lag, right? You'd press W and you'd have to wait 200 milliseconds, which might not sound like a lot, but to your brain is like a freeze of, it's like 20 frames maybe, right? So what happens is your client, your local machine, runs a prediction, and it predicts what the server is going to simulate. So possibly not the most efficient way, but does prevent hacks, and it prevents the latency issues that we're talking about. So then every now and then the server will then say, "Are you here?" And the client says, "No, I'm somewhere else." And then the client may have to do a rollback, and that basically keeps everyone in sync.
Right, and that rollback is basically just sort of restoring the relevant properties of a given instance back to what the server thought. So it could be the position of something, could be the value of something, could even be things like whether it's can collide or not, whether it's anchored or not. All of those different properties, I believe, get rolled back if there's a discrepancy between client and server, which is quite cool. Definitely stops a lot of these things. It even stops things like you making certain parts can collide false so that your character can walk through them, right? The server not only says your character shouldn't go through there, but also restores it back to being a solid object, which is quite cool. So what kind of systems do we need to enable for this to work, essentially? Because this sounds like it might be a bit of a difference to how Roblox has previously worked.
Yeah, Roblox they're developing this technology sort of in parallel with lots of other things. So one of the things that's really designed to fit into it is the new input action system. But because we're talking about things like speed hacking and players' movement needs to be replicated, the original player system wasn't written in that. It was written in something else, some context action service, to be precise. So there's a load of new betas that basically need to be turned on that allow this to work, and there's loads of new features.
So yeah, that new input action service, to my understanding, that's sort of instance-based. So what I mean by that is there's actual items in the game, usually in like replicated storage or actually with this new system within the player, that means it uses the same replication system as other instances to kind of share that state with the server, which is quite a bit different to the previous ones. Context action service and user input service were both sort of just within the scripts, and so that's why there wasn't that sharing between client and server. So shall we run through the settings that you have to enable to get this set up? Because I was looking at this earlier on while producing a couple of demos that we'll show, and there's quite a few settings actually that you have to change for server authority to be enabled. So you actually can't change server authority itself or the authority mode until you've made these changes. So one is that streaming has to be enabled. That is a default on new experiences anyway, but for old experiences you might have some trouble maybe switching over to that if the rest of your code wasn't ready for streaming enabled. You have to set signal behavior to deferred. So again, the old legacy way that signals worked, and this is, if you have something like a part touches another part and you've connected to that signal to do something, in the legacy signal behavior, that used to be evaluated instantly. So it would sort of block the code, and that would be the first thing that the thread does. Deferred essentially defers that until the next loop of the internal game loop, if that makes sense. Then physics stepping method has to go to fixed, so you can't have adaptive. It must be fixed, which means that the amount of time between each physics step is fixed. And use fixed simulation has to be enabled. It's a very similar setting as well. And we'll talk about why those two have to be fixed maybe in a little bit, but that will sort of lock you in at 60 frames a second, for example, for the simulation. And then player scripts use input action system is currently what it's called. I imagine they'll come up with a snappier name or even just force it enabled everywhere, but at the moment you have to turn that on, and that uses that input action service for all of the player control. And then finally, next generation replication has to be enabled. And I think that is where the rollback netcode comes in, because it is just like a special flavor of replication that's going on there. Once you've enabled all of those different things, then you can finally change server authority from automatic to server. And that's it. In theory, out of the box, you've stopped all of the fly hacks, all of the walk speed hacks, anything like that is just immediately stopped by making those changes, which is very exciting. And I imagine in the future, this will probably be like a one button thing, or maybe even just enabled by default, so you wouldn't have to go through all of that setup.
Yeah, one thing I was really curious about is the actual details of how the rollback netcode works, because when I was taking a look at some of the demos, I saw that there wasn't actually any dedicated code that you as the user had to write to handle that rollback. And while I theoretically understand that, like with physics simulation, I suppose Roblox keeps track of, important properties like velocity and position, and then is able to retroactively have the server go look at the player's position and velocity and say, okay, wait, like the server believes that you're here with a speed of this because it's copying all of your inputs simultaneously and then teleports you back to the correct server state as part of that rollback. One thing that I don't really understand is how it understands more complex non-physical behavior that I may want to replicate. Like if I have a sprinting toggle, or maybe I want to replicate if the player's ADSing or something, how does that server version propagate back to the simulation I'm running on the client? Do you know?
Yeah, it's a great question. There's a lot of magic that goes on behind the scenes in terms of when to roll back and sort of which properties it wants to roll back. And I don't think we're super privy to how that works, but with a bit of experimentation in Studio, it's pretty quick in terms of how fast it rolls back. Sort of like next frame, it's already rolled back. And for, as you say, for physics-based things, you really just don't have to worry. If it's within your simulation radius, it's called, around where your replication focus is. Lots of big words, but by default, that's just an area around your character. This is already on by default, and you can turn it on for other instances as well. In terms of non-physical things, I'm not too sure how nicely that works. I think it does have to be based on instances. So, for example, if you had a value that you wanted to keep consistent, instead of sending it over remote events or remote functions, you should use a value object that is somewhere that client and server can both see. And you should be setting that with both if you want to see an instant result. Otherwise, the classic way of being server authoritative would just be to set it on the server and that gets replicated to the client. But yeah, for those sorts of things, everything needs to be instance based. That's why all the player controls and the input context are instance based. It is essentially just a fancy bit of replication, and that's why there's no explicit APIs to ask for a rollback or to configure the rollback behavior. You just say Roblox. By default, it looks around your radius. Like I say, if there's something really far away that you want to be considered as well, you can say, Roblox, please turn on prediction for this instance here. And then you just pretty much sit back and let it do its thing, which I think for beginners or in fact, just for a lot of people who use Roblox, that is the ideal state of just turn this thing on, all your cheating stops, and you just don't have to worry about it ever again. And I think that's the goal of where Roblox want to be with how smooth this works.
Yeah, and this radius-based approach isn't exactly new, right? That's the way Roblox has at least previously handled handing off physical simulation to the client in the past, where before it would simply just blindly trust the client with unanchored parts around within a certain radius of them. Now it's just letting the client run their own local version of those parts and then going back in and correcting over time, right?
Exactly. So in the past, we used to use a bit of API called set network owner if you wanted to have more control over that. And so, for example, in my bowling game, which I'll also do a bit of a demo of later on, because we wanted an instant response and we wanted everything to look nice and smooth, and we didn't want any jarring behavior where the network ownership was changing automatically. When you do your bowling turn, all of the pins at the end of the lane and your bowling ball are owned by the player in terms of network ownership. And that means, yeah, we just trust the player to do the right thing. And for most people, that's absolutely fine. But if someone was using some sort of exploit that could allow them to move any of those objects or change the physical behavior of them, we wouldn't be able to know, and we wouldn't be able to prevent that. Whereas, yeah, with this enabled, now those things would be running on both server and client, and you get that rollback behavior.
It's much less common than it used to be, but we have a bus simulation game, which is, it's not a competitive game at all, but because we do use set network owner on player's bus, anyone who has access to exploits, and we made their sacrificing their computer, putting a virus on their computer, but anyone could download the exploit if you look hard enough. Anyone who does that can mess around with the physics. They can add whatever body mover they want, and they can make themselves go fly, and then they can collide with someone else and then ruin their experience.
Yeah, I'm definitely glad to see the end of the set network owner paradigm. I remember a lot of frustrating hours and days spent on past projects, especially when working with stuff like humanoids and NPCs, where I remember a project where I needed to have a bunch of NPCs that were pathfinding, and I was trying to set their the network ownership so I could have the server tell them where to go. And then sometimes the network model would just kind of freak out and scare itself because a player came by, and they'd suddenly go and temporarily be on the client, and then they'd go back to the server, and then the entire loop would break. And it was quite a painful experience, and very, very far from the seamless vision of Roblox programming that I think Roblox is trying to push.
Yeah, absolutely. There used to be this annoying thing as well where anchored parts can't have network ownership because they're not being physically simulated. And yeah, if you anchored something and then unanchored it, you'd have to then set network owner again, and like that's just a very annoying thing to do. There's definitely some weird code in the lanes that's like has to wait a frame before then calling set network owner again because something's happened, or you've toggled the massless property, you have to set network owner again. It's like why is it so tricky and annoying? So yeah, hopefully a lot of that is solved here.
I remember a lot of task.wait.001s in my code just thrown in there for fun to hopefully get it working.
So shall I start showing a bit of a demo of what I've put together? The first one of these is extremely basic, just a very, very simple billiards demo, essentially, because I just wanted to play around with the new input contexts and sort of see how those synchronize to the server. There is something really cool with the input context as well, which is that you can arbitrarily set the state of those from the client and pass some information over. So it doesn't have to just be in response to like a keyboard press or a mouse move or a gamepad button. You can actually just send information with input context, which is really, really cool. So I'm just going to share my screen, and for those watching, they'll be able to see what's going on here, but we'll also explain it for anyone listening. So this is just Roblox Studio with a server authority test that I set up, and I'll just show you very quickly what it is essentially, which, as I say, is kind of a billiards demo. It's really not very fully fleshed out at all, but you've got some balls, you've got a cue ball and a cue stick that's moving around with the mouse based on where I'm aiming. And then I can hold down the mouse button, it powers up and fires off the cue ball. The physics aren't fantastic, but it's good enough. And so essentially, this is the type of thing where if this was a competitive game and I was playing against someone else, you wouldn't want me to just have full control over all of the physics of the billiards balls. But also you don't want it to be really laggy for me as the person who is taking the shot. I want to see what's happening instantly. And so if I go into players and look at myself, there's this input context folder that was actually created by Roblox's own scripts when setting up the default player control. And so character and vehicle context are just Roblox's ones that they added. But I did this cue control one where I've got firing the cue, the power, mouse position, array position, which I'll talk about in a moment, and a viewport size as well. And essentially what all of these do is the mouse position one, and I don't know if you can see that, it's very, very tiny on the right, but it's keeping track of where my mouse is on the screen using a special type of input action called a viewport position type. And then also viewport size is being sent to the server as well. And from that, the server can literally recreate the ray of where I'm pointing my mouse at, and then can predict where the cue should be pointing. And that's where the client and server code that are both deciding where this cue should be pointing are doing at the same time. So that other players, in theory, should be able to see that. So if I kind of keep the cue pointing towards that middle pocket there and switch to the server, this is what the server's seeing in terms of the cue. So it's exactly the same.
Wow, yeah.
So that's quite cool.
And in the past, just to implement something like this that would replicate would require setting up, I'd imagine, a couple of separate remote events with a loop that was constantly running, reading the input from the client and replicating that.
That's it. Whereas in this case, how this is set up is using a shared module that both client and server can see at the same time, called Q module in this case. And this uses this very, very special API, BindToSimulation. And this is the magic source of having things run on client and server that makes use of essentially all of this new rollback capability. But you don't actually have to think too much about that at all when writing this. You just write your common code that both are doing. So in this particular case, I'm working out where the cue ball is. I'm having a look at where the ray is that's shooting out of my mouse through the screen, if you can imagine that, and sort of working out where should I move the cue stick to. And it's just doing that on both client and server at the same time. And that's it. The rest of it is just Roblox does it behind the scenes. And then there's a few other bits and pieces. So, for example, when the cue is fired, some things happen, and that is just listening to the input context for cue fire. And when it's released, do some other stuff. What you'll see sometimes is if you want to do something within this using the information, but only on client or server, you have to use run service is client or run service is server to determine which one is running this code. And that's really, really important because you cannot manipulate a single GUI instance through BindToSimulation. And you probably only want to affect that on the client instead of the server. So that's why you need to write that in. Annoyingly, even on the client side, you can't edit GUIs within your BindToSimulation function, which is quite interesting. So if you did want to update state based on what was going on here, you kind of need to do that separately based on some sort of signal or a separate loop based on like a render step or something like that. And that's it. It's as simple as that. All of the balls I haven't done anything special with. It is just the physics that comes out of the box. But look what happens if I try and move any of these. They just snap right back to where they were. You literally cannot move them. They just snap right back to where the server thought they were. And that's essentially what stops all the cheating from happening. Because normally exploits would be moving those things around. And I think also if I select a ball and, for example, turn off Can Collide, it turns right back on and went back to where it was. So you just cannot change these properties without the server rolling you back.
And the exact same thing would happen if you were to try and move it around the pool stick using an exploit or like fire off something.
Exactly that. And because you're doing the same code with both, any validation around the max or min limits of something, the power can only go from 0 to 100. If I'm trying to send 200 power, the server is just going to ignore that and set it back to how it was. So what I wanted to do as well is just very briefly show what that same thing looks like without server authority. This is the exact same place. I think maybe a slight tweak because instead of BindToSimulation, I think I had to write like pre-simulation connect because BindToSimulation just doesn't exist if you're not in that. And I had to set network owner to the player for all of the balls, which is what you would have done previously to get that instantaneous response. But as we said, that trusts the player to do the right thing. So now it works all the same in terms of the actual experience. I can fire the cue ball, all of that stuff works exactly as it did before. But now watch what happens if I try and move one of these balls. It's now in a completely different position. Like I've taken control.
Looks like that one's gone underneath the the board. But
it's now gone underneath the table and it's off into.
We've ruined the game.
So you've ruined the game, exactly that. But I could just move the balls that are all of my team into all the pockets and look at that, I've won. There's these kind of hacks that you could do, and in the bowling game that I'll show you in a moment, that would be just knocking over all the pins and you get a strike, and you didn't even have to aim the ball properly. And these are the kind of exploits that if it's a true competitive game, or even if you just want to make sure that the experience is nice and level, a level playing field for everybody, these are the kind of things that you want to prevent from happening. You don't want people to just be able to move the balls through the table or whatever it might be.
But Adam, what if the way I play billiards normally is putting all the balls in the holes myself? It's just so much more fun that way.
Then I think you get kicked out of the competition quite quickly in real life.
Yeah, I guess I might be a cheater.
Exactly. But that is historically been quite hard to tell. As a Roblox developer, with the server being the only thing that you can truly trust, it's quite hard to tell that someone's done that as opposed to just, bowled a perfect strike or done a really, really nice shot with the cue stick. So yeah, this is massively, massively powerful.
With BindToSimulation, there are, I'm aware, some restrictions on how you can code. So I think it's something like task.wait you can't use, or anything in the task library like task.spawn. And there might be some things that don't work, I guess similar to like parallel LU, where there's certain parts of the API that's sort of just turned off. Do you know specifically what impacted you for that, was it difficult?
For this billiards game, it didn't impact me at all because nothing I was doing required us to wait to yield. There was no code that would require you to do that. It is really, really important that nothing from one frame leaks into the next, which is why all of those yielding functions and things that defer code for later are just off the table. So yeah, anything like that you would need to find another way of doing. What you can do is just instantaneous changes that would happen in that frame. So moving positions, changing properties, that is absolutely fine. But anything else is off the table. I'm not really sure why beyond that, other than just that it's bad for it to go from one frame to the next. I think it hampers the rollback ability.
Yeah, I think if you understand the paradigm correctly and act one frame at a time, then it probably shouldn't be too much of an issue. But it might be one of those gotchas for some newcomers about why their code is erroring when they add a wait or a score.
Absolutely, yeah. I think historically, if you were using things like pre-simulation, bind to render step, or pre-render, those kind of things that fire every frame, you really shouldn't be yielding in your code anyway. I think that would be a bad pattern because there's a very good chance that the next iteration of that is happening whilst you're still resolving what happened previously. So if you've been quite clean with that, it'll work here. But yes, prior to this, you could get away with that to a certain extent, whereas here there's a lot of very strict things, and like I say, editing GUIs as well are not allowed within this simulation step handler, whatever we want to call it.
And then another thing that really caught my eye is what I sort of mentioned earlier with the way that the replication or the rollback components require value-based state stuff. Because I remember in earlier like Roblox programming paradigms, it was very common to have objects with a bunch of values in them that represented their state. And then over the years, I think I've noticed as more and more people have switched over to like handling state inside of pure code, just where you have a table representing a player that has their mouse position, their velocity, how much coins they have, or something like that. And this seems like sort of a reversal of that, going back to using attributes and values and that sort of thing, which has always made a little bit more sense to me, quite frankly.
My understanding,
It does feel like we've gone full circle a little bit back to where it used to be, but I think that's quite nice and accessible to people who are using Roblox Studio maybe for the first time or have only just got familiar with it. Generally, seeing what you're setting up in the workspace and being able to tweak things there it is quite nice for that visual learning.
I don't think it is full circle, because the things you describe, right? So like what strafing or like shift, it's like you can do these with input action system, and you can use input action system to fire other things to the server, a bit like remote event, or you could just use remote events. So I don't think you're locked into using values. I think values still are there. They've not been deprecated because a lot of people find them much easier to work with. A lot of people also, like myself, find them to be an absolute mess when things get complicated. But I think the way they've done input action system, you can create these instances with code, and input action system works in a way, I might not be using this term correctly, but it's sort of data driven. It's maybe a bit of a buzzword, but you get the data, you get what's the state, that's what's happening, and then you can deduce what to do. So I don't think it's necessarily a reversion back to the days of storing everything in like an object or a value or a Boolean value. I think what they want is those two potential paradigms to be able to live side by side.
For sure. I mean, I think what I'm really trying to get at is how the rollback stuff handles more complex state stuff that you define yourself. Like specifically, obviously, like I said, it can handle position, and it can say that, okay, if the input is sprinting for 5 seconds in this direction, then their position is logically going to be, force over distance or whatever. They're going to be over here now. But then if you're also trying to replicate more complicated stuff, you are likely going to have those things be simulated and then propagated through a value, because obviously that's how the server rolls you back.
I guess, yeah, if you do have to break out of that one frame thing, because obviously if you're restricted to one frame, you can't store your state in that bind to simulation, then yeah, I'm not sure. I didn't actually think of, like, I guess what custom physics systems kind of applications. I haven't thought of anything beyond the default Roblox physics engine, and I'm aware that some developers have tried to make their own rollback netcode, but yeah, it would be interesting. I'm not sure if it can be used that way, but it would be interesting to see.
Having played around with it, I think it could be tricky to plug into that. You know, I think a lot of first-person shooters and other games that have been competitive and very much rely on knowing where people are and having to compensate for latency and those sorts of things. A lot of those games, especially the big ones, the developers have produced a custom system to deal with some of these problems that are being solved by server authority. And I think if you've made quite a complicated system that solves that, it might be hard to plug this in. And it'll be easier for people who have never considered that at all. And, just with a couple changes to code maybe and a couple settings in Studio, it just works for them. And they've solved something that has been a long-running challenge on the Roblox platform for many, many years. So yeah, I think that's the tricky thing is you can't plug into the netcode for your own, in-script bits of information, and you can't really customize exactly how and like how strong is the latency compensation, or you don't have control over any of this. You pretty much just give them some instances and hope for the best. So yeah, it's an interesting approach. I can see why they've done it this way.
Yeah, and just really quick, I'm still wrapping my head around, but in my understanding of the server authority paradigm they're trying to get us to use, I think one way you can think about this custom states that extend beyond, the like physical stuff like position, can collide, and other Roblox properties is, for example, if you have a sprint system where your player has a stamina value, how that would work is that your player object would have, for example, a stamina attribute that's just an integer between 0 and 100. And then how it works is that in your simulation, what you do is on every single simulation step, you see if the player's sprinting. If they're sprinting, obviously, you do the logical increases in speed. They're physically traveling faster. But then you also decrement that stamina value. And then obviously, if they're at stamina 0, they can't be sprinting anymore. So you disable the sprinting thing. And then how I think the rollback would work in that case is, because obviously, sure, you can teleport them back, but how do you update the actual stamina value to stop people from having, for example, infinite stamina? And I think the way that would work is that as the client is holding down the sprint and its simulation is decrementing the stamina, the server on its own end is also keeping a separate log of that stamina value because it's in the Roblox instance, as opposed to being a variable you pass back and forth through a remote event. And then after a certain amount of time, if the server sees that you're at stamina 0, but then the client's like, nope, still 100% stamina, not using anything at all, it will go in and override that value and set it to 0 just magically as part of the Roblox instance, which I think is a really powerful and much simpler way to handle that kind of stuff.
Exactly that. And hopefully one of the important parts of this, and we talked about it a little bit in the setup, is the fixed simulation step. And that's the other bit of magic sauce, I suppose, here, because in theory, across a given set of time, whether that's 1 second, both server and client should have done the same number of steps and should have progressed through the same amount of time. And therefore, hopefully that synchronization, if they are even slightly out, only needs to happen kind of once to get them back in sync. And then they are both, using the same amount of time. That that sort of initial synchronization, I suppose, is something that's called out in the docs. And I think I'll talk about that a little bit more in a moment. But you kind of need to design around that a little bit just to make sure that you don't get too many jumps back, because everyone has some latency to the server. Unless you're literally sat in the data center, you won't have zero. And so it's sort of how do you hide that initial seam of jumping back? And that's something that, with or without this system, you might want to think about, but it becomes quite obvious with server authority enabled.
That was some interesting insight, Fedor, about values. I think potentially you could look into create values with scripts and using them to track some important state. One thing I was wondering about these implementations is if we have a game that already uses set network owner everywhere, how hard is it to migrate it? Can we just turn it on? Does set network owner still work? Or does the whole game have to be rewritten?
Nice. Yeah, I think this is probably a good time to share the lanes and show you, I've put together a demo of trying to do exactly that, of turn this on with an existing game that uses set network owner, does a couple of, not quite custom physics, but we are changing the velocity and angular velocity of parts every frame as part of the way that the ball rolls down the lane. So let me share my screen for this one as well, and show you what that looks like. So this is the lanes. I'm in studio here in a sort of server authority testing place that I've set up. And I'm just going to hit play and sort of talk through what's going on as we step through this. So this is us in the world, and there interestingly was a little bit of lag the first time I pressed W to move forward. There was like a couple 100 milliseconds of just quick delay, but now as I'm pressing the different keys, I can tell you that this is happening basically instantaneously in terms of moving around. One thing that's quite interesting that I didn't think about until after this is we use a shift to sprint system in here, but the shift to sprint is client side, basically. I only produce it on the client side. So you get this interesting effect of I'm trying to go faster and the server's saying, nope, you're not allowed to go that fast. And then I'm sort of getting this jerky stuff. So I need to redesign this to move that sprint logic to a common module that exists on server and client, or even just do it on the server side, because the reason I did it client side is so that as soon as you press shift, you get that speed boost. And so that might be something I put into a module script that both can see. So if I now go over to bowling, which is the main thing that I am worried about here. So there's these pins down at the far end, which you'll see light up when I enable the lane. And those are previously what I used set network owner on to tell the game that it's my turn to bowl now, and I'm in charge of all the physics of what happens with all of those pins and the ball that I'm going to be throwing down the lane. With this change, instead, I put that common code that is doing things like considering how slippy the lane is and changing the course of the ball. And, we do various custom bits and pieces with it to try and make it feel a bit more like bowling. I put that somewhere common that both client and server can read. Now, did you see that kind of jerk as it left my hand? That's the bit where I think the seam kind of happens that we don't really want, because client and server were sort of disagreeing a little bit at the start as to where that ball should be. And so it sort of just snapped back, and it happened once or twice down the lane as well. Now, interestingly, this is like best case scenario because my computer is running both client and server at the same time. And I haven't added any extra lag here. I am the data center, exactly. And yet there's still just that little bit. It doesn't last very long, but it's enough to break the immersion of a smooth bowling experience, right? And I think that's the key thing that they talk about in the docs. So instantaneous actions using this system, if they're sort of physical actions, can be a bit jarring. And one thing that the docs sort of use as a use case for this, or an example, is say you did something that caused an explosion. That's the type of thing that previously would be like instantaneous. You press a button and something explodes, right? But what might happen is you have an explosion and then the server's a little bit further behind and it goes, oh, no, we're not quite there yet. And then your explosion happens again, and whatever shrapnel was coming out kind of jerks back into position. And what they said in the docs as an example here, or a solution, is to use a fuse wire. So say you lit a fuse wire that lasted a few seconds, and maybe there was some animation on that fuse wire or whatever, but any jerkiness, any rollbacks that need to happen to get everyone in sync happen with the fuse wire, and then when the detonation actually happens, everyone's in sync and it looks really nice, and you don't get any major rollbacks. So that's quite an interesting one. Essentially, whatever your BindToSimulation code is, ideally there's a few seconds for just everyone to get in sync before whatever the critical flow is that happens there. I'm trying to work out how to sort of apply that to bowling. So if I bowl one more time, sort of where in this animation process do I want that kind of synchronization to happen? Maybe I start the simulation binding a bit earlier, because currently, just because of how it was written before, the simulation binding happens there as the ball leaves the hand. Whereas if I make it happen a bit earlier before the animation of the character even starts, maybe I can hide that initial rollback, and anything else that happens is unfortunately just like unstable internet connections or anything else like that. So yeah, it's an interesting one to try and think about, but otherwise worked absolutely flawlessly. The pins I didn't have to touch whatsoever other than just moving that code and deleting set network owner from my code.
Yeah, and that fuse wire example you're talking about is really interesting to me, because I'm currently working on a project that's I can't say too much, but it's going to be very reliant on really rapid movement that is defined by player behavior. Like, players are going to be sliding around, crouching, running, whatever. And one thing that we've made, as we've considered, if we add server authority to this project, is just how smooth it is at the moment in its current state. Because with a very complex simulation where we have a lot of opportunity for players to, like you said, rapidly change their velocity, any kind of like weird snappiness, unsmoothness is going to make the entire system feel terrible and jarry and laggy. And that's almost worse, as strange as it sounds. A philosophy that I've had in a lot of my games is sometimes you need to accept the fact that exploiters will, be able to exploit if it means a better experience for the majority of non-exploiting players. And that's just been a trade-off that I've had to make as a developer, because in the past that cost for preventing exploiters entirely has been too great. So
exactly. And that's why up until this point, we've just trusted the client here, because it matters too much with the bowling experience. We're trying to create something that feels fairly realistic, and that even adults can play this and sort of feel like they're at the bowling alley with their friends. And any issue with the physics of the pins or anything like that would have just been completely jarring, ruin the experience. And so, because it's not competitive at the moment, at most they might farm some extra coins that they can unlock stuff with, but it's not the end of the world if someone exploits here. We use collision groups and other bits and pieces, so nothing they do on their lane can affect anyone else's lanes. It's all well and good. But what we want to do in the future is bring in a tournament mode. We want to have competitions in the game, and now we need to start thinking about, well, cheating might actually ruin the experience for others. It might be more than just being at the top of a leaderboard that has no implication. It now might mean the difference between winning a competition or not. And so server authority for me is sort of coming out at around the right time. But I just need to iron out some of those seams. But the character control, interestingly, is very good. After that initial step, it feels really, really responsive, and it is just that shift to sprint that I'm gonna have to rethink to stop that from happening. But otherwise, it does feel very, very good. Jumping is happening instantaneously. So I'm hopeful that they've put a lot of attention on the character controller. And that sort of player scripts using input action service setting that we had to turn to enabled hopefully solves a lot of that for you out of the box. But custom character controllers, I think similarly to custom physics, you might have a bit more a bit more trouble trying to integrate with this new system.
So to get this right, if you do set net or go now on the side, then will you get an error?
I believe you get an error, yeah. I think that API basically doesn't exist here. The concept of network ownership is not something in server authority because the server is always the owner. And there's no explicit setting. The best you've got is an API that is called, I think it's set prediction mode. And essentially all you're doing there is telling Roblox to consider rollback for this instance, but that's the best you've got. Anything in your simulation radius, it's still owned by the server. It's just you can also run this code on the client if you wanted to. And you could have done that before, but what would have happened before is client and server would have just diverged from each other, and the version that the client is seeing is just completely unrelated to what the server's seeing. So you could have run the code on both at the same time to achieve that low latency look on the client, but the server being authoritative. But what could have happened is my client, for minor discrepancies in physics, thinks I got a strike. The server, with its slight discrepancy in physics, thinks I only got 9, and I get a score of 9. And I go, what? On my screen, it looked like a 10. Like, what's happened here? So this is kind of bridging that gap, but yeah, there's no concept of network owners anymore. It does just error if you try and call that API.
And something you said about the competitive design element of the entire capabilities of server authority really stuck out to me, because that's something, sort of taking a break from the super technical, like physical, programming applications of this stuff. I think what can be really interesting to consider is how this paradigm shift can impact game design on the Roblox platform in general. Because obviously, right, there's been a lot of obvious examples we've talked about, first-person shooters where, like, you can't have a fun experience if people are flying around and teleporting. Driving and racing games where you need to be able to have two objects that are moving quickly and, have them collide or flip out or whatever. But I think another thing that applies more broadly to sort of all of the games we've seen on Roblox as a whole is that for pretty much all of Roblox's history as an online interactive multiplayer game, developers have, sort of had to make the trade-offs I was talking about in terms of accepting that cheating is something that will happen. Like, there's just no way around it. So every single system you design in your game, every single form of currency, every form of progression has to sort of be siloed in for each player as to prevent one cheater from ruining the entire multiplayer experience. And while that works okay in some scenarios where, like, okay, maybe it's a tycoon where it doesn't really matter if one player just unlocks everything instantly because, like, hey, you can still have fun on your own. I think it's led a lot of games into sort of very, very repetitive and kind of dull mechanics, if that makes sense. For example, I was a couple of years back working on this very basic firefighting game where players would go around and they'd put out fires and then they'd earn coins for doing that. And initially, I had this really ambitious idea where, like, the entire world would be shared between players, and then, like, some fires would burn for longer, and then, like, the longer a fire burned, the more valuable it would be, and then there'd be an entire, like, interplayer economy based off the currencies where, like, instead of buying stuff from a perpetual shop where it's like, okay, you can buy the next cooler fire gun or whatever just using like 500 coins, it would be this whole like auction house system where people would determine the value of stuff. But the fundamental issue I realized is that, like, the only way for me to make the actual experience of putting out fires enjoyable was to basically just kind of like have the client tell the server, hey, I put out this fire, that fire, that fire, and that fire, just trust me. And, like, I was able to get some like caps on there. Like, realistically, a player isn't going to be able to put out all of the fires in the map in 1 second. But I had to kind of lean on the side of just trusting the client, which inherently meant that all of the progress those players made couldn't affect other players' experiences, because if there was an exploiter, they could instantly ruin the game for everybody else. So I was forced into this sort of pseudo multiplayer thing, and had to leave a lot of the cooler stuff I wanted to do on the table.
Yeah, it's a really interesting point. I've definitely experienced that before as well in Stepford County Railway, which is another game that I've worked on. We don't want one person's actions to affect other people. And again, a lot of the systems behind the scenes, we've had to code in an exploit-proof way, not detecting exploits and not being completely resilient to exploits on the client who is exploiting, but making sure that that doesn't propagate through to other players and affect their experience. And it is interesting that you wouldn't have that issue with server authority. You're less restricted in terms of what you can design. So yeah, I'm quite excited to see what developers produce based on this. There is also like one nice extra benefit here that talking about Stepford County Railway reminded me, because one thing we did on there is the person who's driving the train is in charge of where that train is and how it's moving so that it's nice and smooth for the driver. Again, prioritizing the person who is in charge of that moving vehicle. But we want it to look smooth for other people as well. And I have this problem with the lanes with bowling as well, which is that when you have a network owner that is a particular player deciding where something is, there's this kind of lag between them deciding where it is, telling the server where it should be, and other clients then seeing it. And sometimes that leads to a bit of a choppy experience for everybody else. If I'm watching someone else bowl, it doesn't look as smooth as when I'm bowling. Whereas one thing you can do with server authority is everyone can be rendering their own version of where things can be. The server's the only one that actually decides where it should be. And this might force people into that kind of paradigm as well, which is something we had to solve ourselves on SCR, on Stepford County Railway. I had to write a custom kind of rendering script that used a lot of remote events and things like that to tell everyone where they should be, and then interpolation happens and all of this sort of thing. But hopefully with this system, again, less thought needs to be provided to that. You just run the same code on every single client, and everyone, not just the person in control, gets a nice smooth experience from it.
And I think, sort of continuing on this topic of better co-experience, I think this server authority feature, while it doesn't seem like that big of a deal for somebody who's maybe not as technical, for the game design benefits, it clearly is improving the quality of co-experience. But I think it's also an interesting step into the future of how you create Roblox games on the platform and how easy it is. Because I think, as anybody who's ever really written any complex exploit resilient game knows, modern Roblox programming requires navigating a server client sort of infrastructure that is pretty hard for new developers to grasp, because there's this fundamental idea that the code you're writing for the client and the code you're writing for the server, even if it's for one object, has to be separate. And there's a whole networking layer where you have to manually copy over states from client to server and update stuff interactively back and forth. And what Roblox has talked about, and we're not quite here yet at the moment with this version of server authority, because you still, like you showed in the demo, have to write one simulation script and then individually call it from both server and client. What Roblox has talked about for the future is something they've nebulously referred to as Aurora script, which, great name, 10 out of 10. I remember hearing it at RDC in whispers, and I was like, what? The Aurora script, it's here?
Sounds so magical and mystical, doesn't it?
Absolutely, yeah. But what they've hinted at, and like I said, this isn't out yet, but the idea is, if we're already having people write one simulation behavior that is then just called on the client and on the server, why do we need the separation at all? Why is it that, when you take all of this information about where your mouse is and position the pool stick and then fire it, why does that need to happen separately on client and separately on server? So what I think they're trying to do is to go back to almost like a more secure version of pre-filtering enabled. If, as I frequently harken back to the good old days of Roblox programming, which is, 10 years ago now, Roblox used to be very much that single script, or sorry, not single script, that's a slightly different thing, but there wasn't this divide in the past between server and client. And to be fair, it was a lot simpler for developers to use. So what I think they're trying to do is almost go back to that, just in a more secure fashion.
Yeah, absolutely. I think I read that Aurora scripts will be renamed, sadly, to
Oh.
behavior script when they do eventually roll out to everyone to remove the mystery and make it a bit clearer what the purpose is. But the idea of a behavior script which can live anywhere in the workspace, anywhere in the data model, and run on client and server. Your car script can just be a behavior script that just describes how the car works, and you don't have to think at all about client and server. It definitely is where they're trying to head towards, and I think the network, the server client model is probably one of the biggest things that I see people struggle with when they're new to Roblox. It is secure. I'm glad that it became the default to have filtering enabled and that it forced people to think about this. But the amount of questions I've seen on Dev Forum, Reddit, all of those about issues with the server seeing one thing and getting that to the client and vice versa. The amount of times I've seen people try and access local player in a server script and trying to access user input service in a server script and wonder why can't I grab the mouse from the server and find where it's positioned? These kind of things are problems that maybe one day we just won't have to solve.
I think this also, just like you said, makes a lot more sense for how to approach programming on Roblox in general, because when you're a creator trying to create some sort of object in the world, what you really should be thinking about is, how does this behave? And I think Roblox is trying to make it as easy as possible to just simply define that minimal behavior and then handle all of the stuff, all the complexities that come with separate clients and servers just on the back end with the magic rollback stuff. Because in the past, when I've worked on games, I remember working on a game where I had a bunch of different animals roaming around in the world, and players could interact with them on a client level, and then the server kept track of key stuff like, their health or what their state was. And I had this really disappointing moment where, like, I conceived the idea of how this would all work in my head, and I'd have these animal objects that would have certain state elements. And then I came to the conclusion that the actually complicated and time consuming part of this would be figuring out how to replicate the positions and behaviors of all of these animal objects to each client, because I couldn't have all those objects on the server. I had to manually send them over. And it was this massive headache of sending massive amounts of data regarding position and health and state. And then sometimes it'd fall out of sync and I need to fix it. And I spent maybe one day implementing the actually interesting stuff that defined the lion roars and the lion eats players, and it makes these cool sounds and you can interact with them. And then I had to spend another week writing buffer code that defined, this is exactly how I'm going to optimize the vector3 thing so it's as little data as possible, so I'm not sending too much stuff to each client when I'm updating 300 animals in one thing. And while it was certainly an interesting challenge, and I'm sure there's a lot of people who probably would really enjoy that kind of thing, I think it doesn't feel as true to the idea of defining just the behavior and then it just working, which is what Roblox is trying to accomplish, I think.
Yeah, I think I'd probably say about 25% of the lines of code in the lanes could probably be deleted if you just didn't have to worry about what was on the client, what was on the server. Both for behaviors like that, but also just, I'd be interested to see how that kind of model would work with data stores or something like that as well, keeping track of clients' data, making sure that they can't edit their balance, but that the information stays synced between the two, because that's quite a big bit of it as well. So yeah, hopefully the future's quite bright with where all of this is going.
Yeah, that absolutely opens up a can of worms of questions about if we could create everything with this Aura script or behavior script, then how does everything work? I think that's probably long away in the future, considering that this is only a studio beta. And we have to remind ourselves that what we're seeing here today and what we're talking about is only an early preview of what is to come. So this whole API could change. We don't know. They may make a load of fixes. They may make it smoother. And we don't know when it's going to release either. We have literally no idea. And the other consequence of it being a studio beta is we can't publish this to a live experience, which means I have no idea how this is going to actually function on a game that handles between 50 and 100 players in a server. We often struggle with our updates because we have a game where so many people are connected to the same server on the same map. And one of the reasons that clients have traditionally been trusted is because it distributes the workload. It's a distributed system. It's much more efficient having each client work out their physics than a single machine trying to work out physics for 50 players. I'm sure probably the interactions between them might be more efficient if you have simulation on the server, and there's probably some optimizations you can make, but we don't know what they are. We don't know what the progress on that is, and we can't tell what the progress is because we can't publish it in our games. So there's a lot that's not known. So we don't know if this is something that's going to work in every game. We don't know if it is the future. Maybe set network owner will still be around for years to come. Maybe people will still be using that. It all depends on what the final version looks like.
One thing that is interesting to note that reminded me is I briefly mentioned earlier about setting prediction mode, and mostly talked about setting it on for things that weren't already in your simulation radius. But one thing you can do is override that and set that to false, which means that you could have, in general, a server authoritative game. But if there was just that one bit that you were like, this is way too inefficient for the server to be deciding all of this, I want the client to decide where something's located and for it not to be rolled back to the server state, you could turn it off for some instances, but then it's up to you to then decide, using remote events or something, if you wanted to share that with other clients. But say you had something that only your player needed to see, and it was very performance intensive, and you decided to not slow down the server with that, you theoretically could do that. One thing as well that was interesting there, you talked about it being smoother. One of the benefits of these kind of systems where Roblox is in control of it is if everybody enables server authority, everyone's using it for all their physics. And today, as I showed a little bit in the lanes demo, it's not quite perfect with its prediction. It can be a bit jumpy, even with minimal network delay. Maybe in the future, Roblox works out how to make that 1%, 5% smoother. Suddenly everyone's experience is way better, rather than one game manages to work out a nice algorithm to make their thing smoother and no one else gets to benefit from it. So one of the nice things about sort of using these out-of-the-box solutions is that any improvements Roblox makes, and of course they have access to a lot of stuff behind the scenes that we don't see in the Lua VM, just gets rolled out to everybody, which is quite a nice benefit. So it can only get smoother and only get easier than the studio beta is sort of the positive I want to take away there.
On that positive note, that's all that we have time for today. Thank you for tuning in to our deep dive on server authority, one of several really exciting transformative features that Roblox are working on in the background and giving us a little preview into the technology.
Be sure to like, share, and let us know your thoughts on server authority in the comments down below. It really helps us grow and reach new audiences.
Beyond the Blox is produced by Seb Jensen for Last Level Studios. Watch on YouTube or Spotify, listen wherever you get your podcasts, and catch updates every week on TikTok and Shorts. Visit lastlevel.co.uk/podcast for more.